What's up guys, here Mr. G with another video for the grade 10s in preparation for the upcoming June examination of end of the year examination. So this time is going to be question 5 from the final for the June examination done at the Northern Cape in 2013. But before we carry on, you can subscribe for the channel so you can get all the notification and videos I post on regular basis. Question 5 said the picture below show an X-ray camera used by dentists, and you can see the camera there. Question 5.1, an X-ray is an example of an electromagnetic wave. Other examples are ultraviolet rays, radio wave, gamma rays, infrared, and light wave. Arrange all these waves in increasing order of wavelengths. So in question 5.1.1, they want to start from smaller wavelengths to higher or longer wavelengths. Okay, that one is question 5.1.1. We're going to do it here. 5.1.1 from smaller wavelengths to longer wavelengths from the radiations that they give you there. Okay, so saying that from there is quite simple. From starting there, the first one is the gamma ray. Remember, gamma ray have the smallest wavelengths and the highest frequency. Second is going to be the X-ray. That one is the second one. Then is ultraviolet. Ultraviolet radiation. Then is the infrared. The infrared, and then is the radio wave. Okay, so if we do that, you need to remember that on this side here, starting from the gamma ray, will have the smallest wavelengths, and then the radio wave will have the longest wavelength. The longest wavelength, but now the longest wavelengths of the ones selected in the question, which are not all of them. Now increasing order of frequency, guys, because it is a this case you need to know that the longest wavelength will have the smallest frequency there, so it's the same one but in the opposite direction. So in this case you will start with radio wave, followed by infrared, then is ultraviolet, X-rays, and then it's gamma ray. Okay, and then in this case, guys, on this side we have the smallest frequency, and then at the end here we have the biggest frequency. Okay, remember, these are not all the electromagnetic radiation. These are just the ones that they mention in this question on this side. Now question 5.2, the wavelength of a specific X-ray is equal to 2,5 times 10 to the negative 11 meters. Calculate the frequency of this wave. Now what they're giving you is the wavelength. This value here is the wavelength of this specific electromagnetic wave, which is 2,5 times 10 to the minus 11 meter. Now, what are the data we have here? Let's quickly go to the table. It's at the back of the question paper. It is here table with constant. Guys, this is an important constant for this topic. This is the speed of light in the vacuum, which is the speed of all electromagnetic radiation. And Planck constant H is also going to be used in this topic, not in this question necessarily, but in this topic. So please remember that one there. So those are the important ones. The formulas, guys, are here on this side. These are the formula for the electromagnetic radiation that we are going to use. We've been asked to calculate the frequency, we have the wavelength, and we have the speed of light in the vacuum. So if we write here the other data, C is equal to 3 times 10 to the power 8 meters per second. It is there at the end. So now we're looking for the frequency. You can see, guys, that in this case C is equal to frequency multiplied by wavelength. And if you substitute everything here, let's just move it a little bit to the up here so we can answer that question. So we have that is 3. Let's just fix it a little bit more to the right there. So it's 3 times 10 to the 8. This is equal to frequency, which we are looking for, multiplied by the wavelength, which is 2,5 times 10 to the power minus 11. When you solve this one, you get that the frequency is going to be equal to 1,2 times 10 to the 19 hertz. It is really simple to calculate. This one is question 5.2.1, guys. It's very simple. Calculate the energy of a photon, and there at the bottom I show you the different formulas you have. It's very little formulas to use, so we're going to use the one. I'm going to show you which one we are going to use. Here at the bottom we're going to use this one because we have everything and it's quite simple. There we just calculated the frequency, so that is what we are going to use in this case here. We are by question 5, so we're going to answer that question here, 5.2.2. You are looking for the frequency, guys. Energy of a photon is equal to h, which is a constant and is given to you there at the bottom, multiplied by the frequency. When you substitute everything, you get that is 6,63 times 10 to the minus 34. That is the value of h, guys. It is given to you, everything multiplied by the frequency, which was calculated, 1,2 times 10 to the 19. And when you do that, it's 19. When you do that, you get that the answer for the energy is 7,96 times 10 to the minus 15 joules. This one is the answer for that question 5.2.2. Indicate the penetrating ability of X-rays compared to all the other above mentioned electromagnetic radiation and relate to its energy. Now, they're talking about, or they want to compare the X-ray with all of the ones that we mentioned here, with all of them, so all of those. Now, guys, the bigger the frequency, the bigger the penetrating ability. You could see in the formula. So if we go to the formula, energy is equal to HF. You can see the bigger the H, the bigger the energy is going to be. They are related. The bigger the energy, the greater the penetrating ability. And you can see here, guys, if you look at X-ray is here. Apart from gamma ray, all of them will have less frequency and therefore less penetrating ability. So that is the first thing I'm going to say. X-ray will have a higher penetrating ability than any other, which are all those there. Remember, this is part of the question, except for gamma ray. Gamma ray is the only electromagnetic radiation here that have a higher penetrating ability than X-ray. It's quite simple. And to finish this question, they say discuss the danger of X-ray on human, guys, and that one is also quite important. And if you ever go to the hospital to do an X-ray, you will see all the protective and things that they do there, so you cannot get damage or certain things there. Alright, so what we have to say here is that X-rays can be absorbed by living cells causing illness. Guys, there are examples of people that get cancer because they overexposed to X-rays and so on. But you can go and search more about the danger of the X-ray. Guys, this is question 5. I hope it helped. If it did so, thumb up, subscribe for the channel. I'll see you next time with another question. Mr. G here.